Hey everybody, thanks for everybody that's joining us, and I want to thank ScyllaDB for hosting me and hosting this amazing conference. Today I'll be talking about how to build modern open data platforms, and more specifically, how to try to achieve this thing called enterprise consciousness, which is real-time data synchronization across your enterprise. A little bit about myself. This is just for context. I started my career building servers and switches and built out data centers. I got into applications, content heavy, knowledge heavy, and then I got into enterprise search because when you have a lot of content, you need to search it, and that's how I got into big data, and that's how I got into real time data, and that's what I focus on these days. Subject matter expert in the Cassandra world, and ScyllaDB is one of the better Cassandra variants, and it's got more than that, but that's why I'm here. I want to talk about how we can use those concepts with ScyllaDB. Today, I'm going to talk a little bit about the playbook that we use to build out platforms. You can always go to our website and see our principles there. But basically, it's broken up into design principles, which framework to use. We have a reference framework we recommend, and then an approach to managing the platform going forward. We're probably going to get to about one or two of the use cases because we have a pretty short time frame here. But my goal is that you walk away with an understanding on how to build out open data platforms for your enterprise and how to make the right choices between cloud native, open source, commercial tools. The big challenge that businesses have is they're trying to connect all of their platforms together in some way or form. This is a graphic from Gartner's paper on digital business technology platforms. And these blocks are just actually categories of platforms. These aren't even platforms themselves. And when we say, business trying to achieve enterprise consciousness, what we're talking about is how can we get information connected and synchronized between systems so that both systems and people can get access to it when they need it. And if you've ever read the Reactive Manifesto or the 12-factor app, there are principles on how to build scalable applications. And so for us, enterprise consciousness goes beyond that and asks, can we do something similar for the whole enterprise? Can we make information available to people when they need it? Of course, secured and governed properly. How to manage cold, raw, and hot data. But eventually, what we're really trying to get to is, can the enterprise be up and running all the time? And we have a recovery point, a recovery time objective of 0. And with technologies like ScyllaDB, that's possible today. But when we think about ScyllaDB is just a database, right? How does the rest of the enterprise benefit from this concept? There are lots of challenges, and we're focusing on data platforms because data platforms are at the center of the business platform. And this isn't anything new. I didn't come up with this, but essentially, most businesses go through these phases of enterprise architecture. There's a really good book called Enterprise Architecture as Business Strategy. It's a Harvard Business School book. I highly recommend reading it for technical and non-technical leaders. But every business starts out with silos. And then they start to standardize, and then they start to create this optimized data core. And that optimized data core is what enables them to be modular and scalable in the future. And ultimately, that's where we get involved. My job is to help people get to that optimized data core. And over the years, the technologies have changed, but this progression has not. Every company has to do this. And if they don't do the step before the optimized data core of standardizing their platform, they basically have to do it again. What is a data platform? Well, everybody has their own definition. I just call it, hey, you got to get data in, got to get data out. There's a bunch of stuff that you have to do inside it. And a data platform is not just one database. There's data warehouses, there's NoSQL databases, there's relational databases, there's queues. But the common element is that there is more and more ingress points coming in for data, and there are more and more egress points for how data goes out. But ultimately, your data platform needs to be able to service those requests. And as a company grows, especially in today's day, there's more and more data, either user-generated, machine-generated, system-generated, that we need to account for. Distributed data helps us with that transformation. Before, when we had monolithic relational databases, there was a limit that we would hit, or you just have to keep buying more and more expensive hardware, and of course more and more expensive software to handle the amount of ingress and egress. With databases like Cassandra and Couchbase and expanded by ScyllaDB, we have the ability to have operational transactional data happening in the same system as analytical workloads, as servicing workloads. And the cross data center replication, this masterless architecture, allows the same exact data to be worked on with APIs bringing data in, APIs bringing data out, and some sort of query or analysis happening at the same time. That magic, when I first found out about how Cassandra could do it, that's really when I dove into Cassandra. And then in ScyllaDB world, which we'll learn about later, is we take that concept and we supercharge it with the better memory management. And of course, it's written in C++, so it's going to be much better. But the concept is the same. We have data in two different places. We can act on it in two different places. The modern data platform is hard to describe. You go Google it. If you talk to ChatGPT, it'll give you some answer as well. Maybe we'll talk on that at some point. But the modern open data platform, everybody has a different perspective, right? And what we try to do is to say, let's forget the technology for a second. Let's think about the context of people, process, information, and systems. Let's think about what are the responsibility areas or departments in the organization, and apply an approach to management using a common framework and with the right tools. So this is the first part of our playbook. The design principles are don't reinvent the wheel, basically. And if you go out on Google and you look for what is a open data platform, or a modern open data platform, what are the modern stacks out there? There's tons of reference architectures. Now you'll notice some logos recurring here and there, and not all of them are really geared towards big data. I think in the medium to small data, there's lots of companies that are saying, hey, you can do this. But when we get to big data, there isn't really a lot out there. And so we take what we learn from everybody else, and we take our playbook, and we go through this design process, the discovery process of let's inventory all the people, all the processes, all the information or objects we need to deal with, and the systems where this data is coming from. Once we have that inventory, we can take a look at a highly opinionated framework focused on real-time big data. Right? There's other databases that do real-time, but they may not be big data. And our focus as a team, is to focus on helping people build big global data platforms. And not every tool works with databases like ScyllaDB. So we have to think about curating this toolkit for what can work with database like ScyllaDB, and can it scale like ScyllaDB. And we're really focusing on the data side here, but there's also a whole slew of tools in the user experience world that allow people to build applications pretty quickly. And that's kind of the new world of technology. Everything is becoming low code or no code. And even the data engineering tools are becoming low code or no code. So the lift of creating an open data platform is much easier today than it was even, let's say, 6 months or maybe 2 years ago. But the goal of managing the platform going forward should be not necessarily programming, but configuring, or clicks, not code, like Salesforce has one of their mantras. If we use the right automations, if we use the right infrastructure as code tools, then the system should really run itself. Of course, we want to add new data. We have to do a configuration. But I want to say, if you were making a new platform today, use as many low code, no code tools out there, because that's the future. Why reinvent the wheel? Why write code that a robot is already writing for you? I've talked about the framework. Framework for us is any component that's out there that meets our rubric. Is it distributed? Is it real time? Is it extendable, or is it open? Does it have APIs? Is it something that we can automate? And of course, can we monitor and manage it properly? So there are certain tools out there that are in the commercial world or the SaaS world that meet 4 out of 5 of these. Open source tools generally fit into this. Every single item in this checklist, an open source tool like ScyllaDB would meet without a problem. You can talk about Spark; it meets these criteria. So we go through this checklist because we want to make sure that if we recommend a tool or if we add a tool to our framework, It's something that can scale to either millions of employees or millions of users, whatever way you look at it. If you go the public cloud native route with, let's say, Amazon, you can build systems that they offer, right? They have a great toolkit. Of course, the problem there is that you can only do it on Amazon. You can't necessarily do it on the same thing. Let's say you're a company that Amazon is competing with because they bought another company. Then what do, right? Same thing with Microsoft. They've got a great toolkit. They have a combination of their own cloud native. They have partnered with companies like Databricks. But ultimately, it's the same problem. You can do the whole architecture on Azure, AWS, or Google without a problem. The question really comes down to is how are you growing in terms of features, and will the features that Amazon or Azure or Google, are they offering features that meet your needs? So for example, AWS has Dynamo, Google has Bigtable. Both of these are kind of, precursors to technologies like Cassandra and ScyllaDB. But they're a little stuck where they're at, right? What can we do now with ScyllaDB? It's like light years ahead of what we can do with Bigtable, or light years ahead of what we can do with Dynamo. Dynamo is still a good API layer, but what we can do with ScyllaDB with the CQL layer is just amazing compared to what we could do with just DynamoDB or even Bigtable. I mean, it's kind of funny. We look at how to talk to Bigtable these days, and we're really just using tools from 10 years ago or 5 years ago. So I'm not saying you should do everything on cloud or don't do anything with public cloud native technologies. What I'm recommending is try to optimize what are the right tools we want to use with the cloud native offerings, combination with tools that we know are the best of breed. And there are lots of open core distributed data platform technologies out there, from the data storage layer to the processing to the query layer, as well as streaming and stream processing. And every technology out here is either open database, open source, or it's open core. There's also as a service offerings out there that mimic a particular technology. Let's say Amazon Keyspaces or Cosmos DB, but they're closed in the sense that they're only available on Azure. However, if you use ScyllaDB, you can host that database on any cloud and essentially switch between clouds if you needed to. And you know what? One of the clients said it's not necessarily that they're going to switch clouds that they care about, openness. It's that maybe they have a customer, maybe they're on Google Cloud, let's say, right? And their software is meant for business. Well, what if a company comes and says, I have everything on Amazon. I only want to use your software on Amazon. And, what do you do then, right? Are we going to send data to you on Microsoft or Google, a separate cloud to process and bring it back to me? Or can I just host your tool in my cloud? And if you're building software, this is a big requirement. Can it run on different clouds? But if you're building enterprises, you can think about, what happens if Amazon or let's say Google or Azure, not that they're going to go down. I think that was like an argument before for multi-cloud. But, let's say that they start to get into your industry. How do you pivot from one cloud to the other? Technologies like, open source technologies like ScyllaDB can allow you to switch between clouds because you can literally move the database over, even have it work on both clouds at the same time without having any downtime. And that applies to Spark. That applies to technologies like Kafka as well. Beyond the actual data platforms out there, there's lots of great automation and integration tools that are available that are open source. We have catalogs, data catalogs that are open source. We have orchestration tools like Airflow that can help with not only orchestrating infrastructure, but also orchestrating the different pipelines that are out there. We have low-code tools like Grouparoo and Airbyte, which we'll take a look at a little bit later. We have systems like PostHog that basically can mimic and different user analytics tools, and that data is stored in an open database. So in addition to the open data platforms, there's a whole collection and growing collection of tools and technologies that we would normally pay a SaaS company or a platform as a service company, and that data is locked in there. Today, we can just bring it in-house. And maybe 5 years ago or maybe 10 years ago, I would say, don't host it yourself. It's a pain in the neck. But with Kubernetes, basically everything can be hosted pretty easily. I'm not saying that it's a catch-all to make everything easy, but with the standardization of Kubernetes across all the clouds, all of these tools and technologies can be deployed the same exact way, pretty much, across all the different clouds. In the BI tool space, we have a growing toolkit like Metabase or Redash. And of course, on the data processing side, we have things like Airbyte, and RudderStack is another competitor to Airbyte. So every time we're talking about open core or open data platforms, we're talking about technologies that you can either pay that company to host for you, or you can do it yourself. And when we bring all of these components together, we look at it as a computer. And a computer that can be built in different strategies. There can be an open source strategy to build that computer. There can be a Google native a strategy to build that computer. But ultimately, it's a combination of these tools that is right for the business. It's not one thing meets all the requirements. Every business is slightly different. And your business may need something that is both open source and Google native. Or maybe it's AWS and Google and open source. This reference architecture kind of brings all this together. It combines low-code, no-code tools from data processing for user interface, as well as tools to bring out APIs pretty quickly. The lower level of it is really data and DevOps heavy. And we put these things together because these are common elements. We didn't come up with the architecture. Spark, Cassandra, Kafka has been a trio that's been used for many, many years. Today, you don't have to use that. You can use Spark, Scylla, and let's say Red Panda if you wanted to, right? They're kind of synonymous technologies. Once you have a platform, we have to manage it. And management basically for us is a simple way of documenting the stack. Setup, training, administration, customization, and knowledge management. This is the single most important thing in a platform is once you build it, how are you going to manage it afterwards? And we have a schema that basically makes it easy for people to have one knowledge base. Whether you do it in Confluence or Markdown doesn't really matter, but a standardized way to make sure any platform you're creating is documented like a software product that you'd be publishing for other people. You keep it in-house for your team members. Bringing it all together for this enterprise consciousness, the standard data fabric, we talked about how Cassandra came out with the cool technologies that are out there. ScyllaDB has gone light years ahead. They have better memory management, better CPU management. It also has a Dynamo layer if you want to use that to get off of AWS. And getting data into ScyllaDB is much easier now. There's lots of tools like Airbyte and Rudder. You can continue to use Kafka Connect or Pulsar IO to do this. And once it's in there, there's technologies that you can use to serve it out pretty quickly. You can also send data back using tools like Grouparoo. So you have data that's coming in, you're processing it, you're serving it, you can serve it out. Why is this important for enterprise consciousness? This is the main reason why we're talking about today, is that technologies are easier to get data in and get data out. And this is what the complete picture looks like. Now, you may not use any of these tools. So I'm going to give you one specific example that may resonate. So imagine you have HubSpot, MailChimp, QuickBooks. You want to get data into ScyllaDB. Airbyte is a good tool to bring it into an operational data store. You can do some Spark analysis to make your master data store. And then once you're happy with it, you can serve it out using GraphQL or Dynamo's interface. The alternator interface. And if you want to send it back, you can use Grouparoo to send that data back from your master data store out to HubSpot and QuickBooks. This technology is all low code. And when you think about implementation time, we're talking about days, not weeks and months. Key takeaways: don't reinvent the wheel. Identify your objectives, identify which objects you want to move, prioritize DevOps and data ops because somebody's going to maintain it. Let a robot maintain it, run it for you. Use open tools as the preference, and then finally document it. The next employee or the staff member that comes on, it shouldn't be a chore for them to understand how the whole system works. Thank you for having me here today, ScyllaDB. And if you're interested in some of the stuff we talked about, check us out. We have tons of great content out there on our website. We have a weekly webinar series for data engineering and for Cassandra topics, where we also cover ScyllaDB. And anytime you want to reach out, you can also reach out to me. Happy to help. Thank you again, everybody, for coming, and looking forward to talking to you guys in the future.